Approximate values of angles. How can you find the measure of an angle when the value of the trigonometric ratio is given? To reverse the process, for instance, to find the measure of theta, the measure of the angle, if we know the value of the ratio, we can use inverse trig functions on the calculator. So, for instance, something we know is that sine 30 is 1/2. Right? And just to remind ourselves that if we had a reference triangle, right, and here is theta, right? So if this side is 1, if the opposite side here is 1, of course the adjacent side in this particular example would be the square root of 3, and the hypotenuse would be 2, right? So then sine theta would be 1/2, and what angle measure has a sine ratio of 1/2, right? Well, that's going to be 30 degrees if we're in degrees, or if we're in radians, pi/6. Right, so we're going to be solving here for the angle measure. And these aren't always going to be nice, pretty values. So it won't be that we can always just draw a reference triangle and figure out the answer that way. So we're going to use the calculator to approximate the values of angles when our measures might not come from a special right triangle. All right, so the keys that we're looking for when we're going the other way have this that -1 on it, and that is an abbreviation for the inverse of sine. Right? We have some other names for it. Sometimes we call it arcsine, right? But we're going the other direction. We know the ratio, we want the angle. Now, don't confuse inverse with reciprocal. Right? So the reciprocal just means it's flipped, right? So the reciprocal of sine is cosecant, right? So sine, and it actually needs a variable, so we'll give it a theta, terrible looking theta. Sine theta is the same as 1 over cosecant theta, and likewise cosecant theta is 1 over sine theta. They're reciprocals of one another. That's different than inverses. So the inverse of sine is written like this, or also called arcsine. Right? So with arcsine, we are going, and this thing is a C, we're going from the ratio back to the angle. And we did solve some problems like this in both geometry and algebra 2, so it won't be completely new to you. All right, so the calculator keys, so sine with the -1, that's arcsine. Cos with the -1 is arccos, and tan with the -1 is arctan. Return one answer only. Right? So when we use the calculator, we are going to get just one answer. However, there's often going to be two angles with the same trigonometric function value in any full rotation. So when you were in geometry and algebra 2, we just solved for the one answer. All right. So now we're going to also solve for the other answer. Right? Because if you remember, our values repeat, right? So if you think about sine, right, we get the same values in the first quadrant as we do in the second quadrant, because sine is positive in the first and second quadrant. Cosine, we get the same values in the first quadrant as the fourth quadrant, right? Because cosine is positive in the first and fourth quadrant, and so forth. So for every full rotation, we actually have two answers. So when we were solving problems in geometry, we were just looking for an angle and a triangle. Now we're looking for an angle in the coordinate plane, and so we're going to use reference angles to find our other answer. So let's take a look. All right? You might be asked to solve in radians. You might be asked to solve in degrees. All right? So here, if we're told that our answer is in the domain of 0 to 2 pi radians. 2 pi, that means we're working in radians. Right? So A there is in radians, D is in radians, and B and C are in degrees. Notice it's not the same one each time, right? So we're going to have to figure out where we are on the coordinate plane. All right, so let's look at the first one. All right, so we have sine theta equals 0.879. So not a value from one of our special right triangles, right? And actually, if you at least the first two are not, right? So we can go ahead and we're going to solve this one. But first of all, let's think about where our answers can lie. Right? So we're told between 0 and 2 pi. So we want to graph this. Right? So 0, pi halves, pi, 3 pi halves, and 2 pi. If you notice, our value is positive. Right? So 0.879 is greater than 0. Right? So that means we are not in the third quadrant. And we are not in the fourth quadrant because sine is negative in those two quadrants. We are in one of the first two quadrants. All right? So we can be in the first quadrant or we can be in the second quadrant. We'd actually get the same values. All right? So let's solve for the first one, and then we can use reference angles to solve for the next one. All right? So to get rid of sine, the inverse is arc sine. So we're going to take the arc sine of both sides. It's just like if you had something multiplied together, well, the inverse of that would be division. Right? You want something that undoes. Right? If you were raising to a power, the inverse of that would be a root. So we are going to take the arc sine of both sides to get our first answer. All right, so sine and arc sine are inverses of one another. They cancel each other out. That gives us just theta over here. And then we are going to use our calculator to calculate this out and find the angle measure. All right, so we're going to use the calculator to get the first one. We're going to use reference angles to get the second one. And I did hide this where I could see it. All right, there we go. So I am in degrees. That's no good. I need to be in radians. There we go. All right, so 0.879. All right, I type in my ratio, and then I need the arc sine. You'll generally have to hit shift on your calculator to get to arc sine. Right, and then I hit arc sine, so this is a backwards calculator. I need to do the angle, the ratio first, and then hit arc sine to find my answer. And so this is in radians, so I'll round to 4 decimal places. So this will be 1.074 radians. Oh, 1.07, I said 4 decimals, 38. 1.0738. All right, so theta here is 1.0738. Yeah. All right. So it'd be nicer, right, if it had pi's when we're trying to figure out where it belongs. All right. So step one. This is step one. Actually, step one is figure out which quadrants. Step two is go ahead and solve. So step two is solve using inverse trig ratio. Step three, it's going to give you go back there and graph. And the step one just kind of gets you focused on, okay, which quadrants I'm going to be on when we're trying to graph. Right? We'll let's just graph first, and then we'll continue. All right, so we have 1.037. All right, so we know what this is. This is 3.14 approximately. All right, and so if we take half of that, we can find the calculator. Right, so if we take, or we can even just do pi divided by 2. Right, so 1.5707. Actually, just put 1.57. So 1.57 is about pi halves. So we can see we got the answer for the first quadrant, and that's kind of to be expected, right? So when you solve, the answer that you're going to get is the first quadrant, right? So this right here, that's our 1.0738. All right, that's our first answer. All right, so now we need to figure out the other answer. All right, so we have a reference angle in the first quadrant. We can have a reference angle in the second quadrant, because the second quadrant is also going to have the same sign for sine, right? And that's the whole purpose in figuring out which quadrants it's going to be in. My other angle is going to be here, right? So it's going to have the exact same reference angle. 1.0738, right? So remember, we use reference angles to evaluate trig ratios. It's not the actual measure of the angle. It's the measure of the angle we can use to evaluate with, right? So, and everything about it is the same except for the signs can be different. In this case, though, we purposely made sure we chose the other quadrant where sine would be positive. All right, so that's the measure of the reference angle, 1.0738. So we graphed the angle. We graphed angle in other appropriate quadrant. We need to figure out, I'm going to write in another color so you can see it, what this measure is, right? Because the answer we get for this angle here and the answer we get for the actual angle are going to be the same. That's the whole point of reference angles. All right, so in this case, we're not solving for our reference angle, we're solving for our principal angle. So this here is the reference angle. This here is the principal angle. And notice that in the second quadrant, and together, and so after step 4 is going to be to solve for principal angle. So together, the two angles equal pi, right? So together, the principal angle plus the reference angle equals pi. All right, we know the reference, oops, he's not supposed to have a, he's the principal angle. The reference angle we know is 1.738. If we simply subtract that value from pi, we will have the value of the reference angle and the other angle that has the exact same trig ratio. And I'm not that great at subtracting decimals in my head. All right, so pi minus, and it's 1.0738. All right, so 2.0678. 2.0678. There we go. And now we have the other angle. So we have our two answers. All right, we have this one here in the first quadrant, and we have this one here in the second quadrant. So there's going to be a little bit more work involved here and a little bit more having to think than just solving like you did in previous years. And that's because we're now looking for two answers. Right? And let's actually see what happens if we, so if that's our angle measure, what happens if we take the sine? I'm in radians. Okay, so there's our value of our angle. If we take the sine of that, notice what we get. Well, we should feel darn good because we get 0.879. All right, so that's how you can check yourself, is when you got the answer, go ahead and, whatever the trig function is, take the sine or cosine or tangent of that value, you should get back to your original ratio. So we have two answers here. And of course it won't be exact, right, because this is a rounded value. So our final answer is, so sine 1.0738 equals 0.879, and so does sine 2.0678. That also equals 0.79, rounded to 3 decimal places. Right? And this is a good place to stop for this video. And then I'm going to do the next problem on the next video. All right, so our steps. Step 1, figure out which quadrant you belong in, all right, because that'll help you set up the rest of the problem later on. Step 2, just solve like you would normally. Take the arc sine, arc cos, or arc tan. And if it's not sine, cosine, or tangent, we're going to have to be a little bit more creative. Step 3, graph your angle so you can see where it is. Graph the reference angle in the other appropriate quadrant. And maybe I should make that clear, because there's two angles there. So let's call it the reference angle in the other appropriate quadrant, and then you just solve like instead of solving for the reference angle, you're actually solving for the principal angle, right? But the steps are basically the same. All right, so I'll see you in the next video. We'll do another problem together. Right, bye for now.